Hello, science adventurers. Today we're diving into quantum light, a technology set to transform our world. Regular light, like sunshine, is made of countless tiny particles called photons, but quantum light lets us control individual photons, even entangle them. This means ultra-secure communication, powerful calculations, and seeing with incredible detail. The breakthrough? Tiny quantum light factories can now be built onto microchips. These chips generate and guide single photons, all on a space smaller than your fingernail. Now, we can mass-produce quantum devices, bringing this tech into everyday life. Quantum light isn't just an upgrade, it's a whole new way to power technology. Get ready for a revolution in how we communicate and understand our universe. Let's compare the old and new ways of making quantum light. The old way? A room full of lasers, mirrors, and delicate equipment, expensive, fragile, and impossible to scale. Even a tiny vibration could ruin an experiment, and every part needed constant expert attention. Now, with photonic integrated circuits, PICs, we etch microscopic channels into a silicon chip to steer light precisely. Lasers, splitters, filters, and detectors can all be miniaturized onto a single chip. This makes the system stable, robust, and cheap to mass produce. Millions of quantum chips can be made using the same techniques as regular electronics. Suddenly, building quantum computers or deploying quantum sensors becomes an engineering challenge, not a scientific fantasy. It's the difference between a handcrafted violin and a mass-produced electric guitar. One sparks a revolution. The future of quantum technology is small, stable, and scalable.
Thank you, Emily. In quantum computing, scale and quality are everything. Qubits, quantum bits, can be both 0 and 1 at once, letting us explore vast possibilities. Photons make excellent qubits. They're fast, stable, and can be entangled. But we need millions of identical, high-quality qubits, something old lab setups couldn't deliver. Chip-based quantum light sources are game changers. They're our brick factories, producing thousands of perfect single-photon qubits per second. We can now design chips that create, manipulate, and measure photons all on one platform. This integration reduces errors, boosts speed, and paves the way to million-qubit processors. With these chips, we're not just building experiments. We're building real machines. Imagine simulating molecules to discover new drugs, or designing revolutionary materials. Problems too complex for today's computers. Photonic quantum computers powered by these chips could solve them. We're on the verge of building the most powerful problem-solving machines in history, all thanks to our ability to mass-produce perfect single particles of light. The future of computing is quantum, and it's almost here.
Now, let's hear from Professor Ben Carter, expert in quantum communications.
Thanks. My passion is making information perfectly safe. Today's digital security relies on math problems that quantum computers could break. We need security based on physics itself. Enter quantum key distribution, or QKD. QKD sends secret keys encoded on single photons. If anyone tries to intercept them, the act of measuring disturbs the photons, revealing the eavesdropper. It's like a message that self-destructs if tampered with. Unbreakable security. Old QKD systems were bulky and expensive, but chip-based quantum light factories change everything. Now we can build tiny, affordable QKD devices for banks, hospitals, even your home router. These chips also let us create entangled photon pairs, enabling even more advanced secure communication, the backbone of a future quantum internet. We're not just making messages safer, we're building the infrastructure for a new era of connected technology. Quantum chips are the key to a truly secure digital world. The future of communication is unbreakable, and it's coming soon.
Our final expert is Dr. Lena Petrova, a leader in quantum sensing.
Thank you. While others process and protect information, I focus on gathering it. Quantum sensors use photons' extreme sensitivity to measure the world with incredible precision. In medicine, they can detect the brain's tiny magnetic fields for safer, more detailed imaging. In the environment, quantum sensors can spot pollutants at levels current tech can't reach. These chip-based sensors are small, affordable, and robust, deployable anywhere. We're about to see and measure our world, from neurons firing to gravitational whispers, with clarity we never thought possible. We're building a global nervous system for our planet. The future is clearer than ever.
Let's bring our experts back for a final thought. What does a scalable quantum light factory mean for everyone?
It's about democratization. Mass-produced quantum processors mean anyone, startups, researchers, can access quantum computing power.
For communication, it's about trust. Imagine a world where your data and privacy are protected by the laws of physics, not just passwords.
For health and safety, quantum sensors could catch diseases earlier or prevent accidents, real, tangible improvements to daily life.
The quantum light factory is where computing, communication, and sensing converge. Future tech, like self-driving cars, will use quantum sensors for navigation, quantum communication for security, and quantum computers for real-time decisions. These technologies will work together, powered by our ability to control the smallest particles of light. This tiny chip is the seed for a new technological ecosystem. The impact? A smarter, safer, and more connected world. The revolution is on a chip, and it's just beginning. Get ready for a quantum-powered future. Today, we learned that quantum light, controlling individual photons, is unlocking a new generation of technology. Chip-based quantum light factories make this possible, bringing quantum power to the real world. Dr. Sharma showed us how these chips are the missing piece for powerful quantum computers. Professor Carter explained how they'll secure our digital lives with unbreakable communication. Dr. Petrova revealed how quantum sensors will give us new superpowers to see and protect our world. The most exciting part? This is just the beginning. Like the microchip before it, quantum light will inspire inventions we can't yet imagine. By mastering the smallest particle of light, we're making our world faster, safer, and healthier. The future isn't just bright, it's quantum bright. Stay curious and get ready for a world powered by quantum light.